Hello, everyone. My name is Xiaochen Liu. Today, I would like to introduce my presentation for CDPR 2023. And my paper's title is Decomposed Soft Prompt Guided Fusion Enhancing for Compositional Zero-Shot Learning. My poster number is 282. First, I would like to describe what traditional zero-shot learning is. Zero-shot learning aims to recognize novel classes that are not seen in the training stage, like zebras. The model is only trained on horses, tigers, and pandas, while zebras have some relative attributes such as horse, stripe, and black. Based on these classes, models could learn the ability to transfer knowledge from seen to unseen classes and predict the novel class. As a classical branch of zero-shot learning, compositional zero-shot learning aims to identify the composed concepts like state plus object. For example, given a young tiger and an old cat in the training stage, compositional zero-shot learning needs to recognize the young cat and the old tiger in the testing stage. Some prior algorithms designed two classifiers to identify state and object separately, while these models overlook the intrinsic relationship between them. After the primitive concepts are obtained, the association between state and object could be established again through a graph neural network or external knowledge compositions. Nevertheless, these are post-processing methods, and these classifiers are separated from image features with strong correlation, ignoring entanglement. Some other methods are to directly treat the combination as an entity, converting CZSL into a general zero-shot recognition problem. Generally, the visual features are projected into a shared semantic space, and the distance between entities is optimized, such as Euclidean distance. In summary, these methods are all visual recognition models, which are limited by the strong entanglement of states and objects in image features. Based on CSP, we improve vision language models on compositional zero-shot learning. Here is the motivation of our methods. Our method aims to narrow the domain gap between seen and unseen compositions by fusing decomposed features FO and FS with image feature FV, while learn the joint representation between state and object in language. Branch. Being fused with the state and object features, image feature can learn the response of them respectively and improve the sensitiveness of unseen compositions. The framework of our proposed DFSP, which consists of Soft Prompt Module, SPM, and Decomposed Fusion Module, DFM. SSPM aims to construct and preserve the joint representation of state and object, then convert the discrete prompt to learnable soft prompt, causing the extracted language features FT more discriminative and more suitable for new tasks, especially CZSL. There are three forms of decomposed fusion in SPM, BIF, I2T, and T2I respectively, and if the fusion method is T2I, only decomposition exists on the language to image branch. Meanwhile, decomposition and recomposition coexist in the fusion method of BIF and I2T. After decomposing language feature into independent state feature FS and object feature FO, DFM fuses them with image feature FV and calculates similarity in the final pair space. DFSP can not only learn the joint representation of state and object, but also shrink the domain gap of seen and unseen composition sets. Here are the results of our methods under the settings of closed world and open world on the three datasets MIT, UT, and CGQA. As we can see, DFSP outperforms other methods by large margins. Here is the pseudocode and visualization of qualitative results. The design of DFM has three key points for DFSP. I. DFM only decomposes the language features, in which state an object has less entanglement. Since state and object are separated in text, they can be decomposed easily and precisely, which preserves the joint representation of state and object. 2. The decomposed state and object features are fused with image features to realize information interaction between the two modalities. Meanwhile, DFM establishes respective associations of the image with the state and object, improving the responsiveness in the pair space, especially for the unseen compositions. 3. If there are many categories of states and objects, the composition set will be particularly large, limiting the performance of the model. DFM can reduce the complexity of the composition from n times m to n plus m.